Facebook has nearly 3 billion active users. Every day, millions of public posts.
But try tracking even 20 brand pages manually. Copying post text, counting reactions, reading comments, it would take days. And by the time you're done, the conversation has already moved on. That's where web scraping comes in, basically telling software to visit pages and grab specific data for you automatically. Today, I'm showing you how to scrape Facebook data cleanly, step by step, even if you've never done anything like this before. And at the end, I'll show you a full working Python script you can run yourself. Stick with me till the end. I'll walk you through a clean scraping setup, explain why GoLogin beats every other tool for this job, show you the actual Python code, and at the end, you'll find out how to get 40% off GoLogin plus 2 gigabytes of free proxies, so you can start extracting data with way less risk. Here's what's actually worth extracting from public Facebook pages: post text and media, what brands and communities are publishing, comments and replies, the real conversation happening around content, reaction counts, likes, shares, and other engagement signals, page metadata, follower counts, descriptions, posting frequency, group discussions, public community threads on specific topics. Market researchers track brand sentiment across thousands of posts. Competitor analysts monitor rival pages to see exactly what content drives engagement. Academic researchers study how information spreads through social networks. Ad teams track public reactions to campaigns in real time. Facebook's terms of service restrict automated data collection. Be aware of that before you start. Stick to publicly accessible data, respect rate limits, and don't scrape personal information without a clear legal basis, especially under privacy regulations like GDPR or CCPA. A pro knows this and plans accordingly. Facebook has one of the most aggressive anti-bot systems on the internet. Here's what it actually checks, and why simple tools fail. Facebook builds a unique ID from your browser's signals: screen size, fonts, graphics card, audio processing, not just your IP. Two people on the same Wi-Fi, same browser, still look completely different to Facebook. Facebook analyzes how you interact with pages, how fast you scroll, how you click, whether your request patterns look human or robotic. Scripts that load pages in a perfect rhythm with no mouse movement get flagged immediately. Facebook's actual content, posts, comments, reactions, doesn't exist in the raw page code. It all loads afterward through JavaScript. A basic scraper just gets an empty shell and has no idea what it missed. Aggressive rate limits kick in after relatively few requests. Push past them and you get an IP block. And Facebook flags data center IPs, the kind from server farms, almost instantly. They don't look like real people. Real example, a social media analyst was tracking competitor page engagement. They ran a basic scraping tool with no proxy. After about 30 page loads, Facebook started serving CAPTCHAs on every single request. Their IP got flagged as automated. With an anti-detect browser and a residential proxy, those same 30 pages would have loaded cleanly, because Facebook would have seen a normal person browsing from a real home connection. An anti-detect browser makes automated browsing appear much more like normal human activity. It hides the fingerprints that websites use to identify bots, gives each browsing profile its own separate identity, and pairs each one with a different proxy so requests come from different locations. This allows multiple sessions to run independently without sharing cookies or other tracking data. When scraping dynamic websites like Facebook, these browsers can load pages the same way a regular user's browser does while presenting a more consistent browsing profile. In comparison, basic scraping tools often struggle with JavaScript-heavy content, and standard automation frameworks may expose characteristics that websites can detect. By combining realistic browser behavior with isolated profiles and proxy support, anti-detect browsers are designed to reduce the likelihood of being identified as automated traffic. Why I like GoLogin for Facebook scraping. I've tried a few anti-detect browsers, but GoLogin is one of the easiest to work with. First, it uses its own Chromium-based browser called Orbita, which is designed to provide a more consistent browser fingerprint than a standard automated setup. Another thing I like is that it handles a lot of the profile configuration for you. When you connect a proxy, it can automatically match settings like time zone and language so you don't accidentally end up with an IP from one country and browser settings from another. Each profile is also completely separate. It has its own cookies, storage, and proxy, so sessions don't interfere with each other. If you're automating tasks, there's a Python API that lets you create and manage profiles directly from code instead of doing everything manually. And because you can keep using the same profile over time, your browsing environment stays consistent rather than looking brand new every session. Those features make GoLogin a convenient option for people who need multiple browser identities and want to automate browser-based workflows. Start by downloading GoLogin for your operating system and signing in. Once you're on the dashboard, you're ready to create your first browser profile. Click Add Profile and give it a name you'll recognize later, like Facebook Research or Competitor Tracking. It doesn't matter what you call it as long as it's easy to find. Next, head to the proxy section and paste in the credentials from your provider. Most people use either an HTTP or SOCKS 5 proxy, along with the host, port, username, and password. Hit Check Proxy. If everything is configured correctly, you'll see the connection succeed and the detected location appear. If it fails, it's usually just a typo or an incorrect credential. Save the profile and click Run. GoLogin will open a separate browser window that's isolated from your normal browser. In most cases, it also aligns settings like time zone and language with the proxy automatically. Before visiting Facebook, open IPHey.com and make sure your browser looks consistent. You want the IP, time zone, language, and other browser signals to match the profile you're using. If something doesn't look right, regenerate the fingerprint and test again. Once everything checks out, open a public Facebook page. Because you're using a full browser, dynamic elements like posts, comments, and reactions can load normally instead of just downloading raw page code. At this point, you've confirmed that your profile is working, your proxy is connected, and your browser environment is configured consistently. You're ready to move on to the next stage. Now that the browser is set up, it's time to automate the process with Python. Before writing any code, install a few packages that we'll use throughout the project. First, clone the GoLogin Python wrapper and install the extra libraries. So what do these libraries actually do? Selenium is what controls the browser. It can open pages, click buttons, type into forms, and scroll just like a real user. WebDriver is the bridge between your Python script and the browser itself. Gives Selenium different ways to locate elements on a page, whether that's by class name, ID, CSS selector, or XPath. Keys lets you simulate keyboard actions like pressing enter or tab. Time.sleep simply pauses the script for a few seconds while pages finish loading. GetPass is useful when you want to type passwords securely without displaying them in the terminal. Pandas makes it easy to organize your scraped data and export it to CSV or Excel for analysis. And finally, GoLogin's Python wrapper connects your script to the browser profile you created earlier, so everything runs inside that isolated environment. Once these packages are installed, you're ready to write the automation code and control the browser directly from Python. Now let's put everything together. This script launches a GoLogin profile, attaches Selenium to it, signs into Facebook, opens a target page, scrolls to load more content, extracts the text from each post, saves the results to a CSV file, and then closes the session cleanly. I'll walk through each section so you can see exactly what's happening. Step 1. Connect to GoLogin. Before we can automate anything, we need to connect the script to GoLogin. Start by opening GoLogin and heading to Settings, then API Access. Generate an API token if you don't already have one, then copy it. Next, find the browser profile you want to use and copy its profile ID. That's what tells the script exactly which profile to launch. Once you've got both values, just replace the placeholders below with your own. After that, we're ready to start the browser. Step 2. Launch the GoLogin browser. Now that GoLogin knows which profile to use, it's time to launch it. When we call gl.start, GoLogin opens that profile in the background and gives us a debugger address that Selenium can connect to. Instead of opening a brand new Chrome window, Selenium attaches to the GoLogin browser that's already running. That means every action we perform uses the profile, fingerprint, and proxy we've already configured. Step 3. Open Facebook. With the browser running, let's head over to Facebook. We'll also maximize the window and give the page a few seconds to load before interacting with anything. Step 4. Log in. If you're accessing content that requires an account, this is where you'll sign in. I'm storing the email directly in the script for this example, but notice that the password is requested with GetPass, so it isn't displayed in the terminal while you type. Step 5. Choose the page you want to scrape. Now it's time to tell the script where to go. Just replace the URL below with the public Facebook page you want to collect data from. It can be any page you're interested in researching. Facebook doesn't load every post at once. As you scroll down, more content is fetched automatically. This loop scrolls to the bottom 3 times, giving the page a chance to load additional posts each time. If you want to collect more data, simply increase range to a larger number, like range open parenthesis 5, close parenthesis, or range. Just remember to increase the delays as well so the page has enough time to finish loading. Once the file is saved, the script closes the browser and stops the GoLogin profile to clean up the session before exiting. At this point, you've successfully scraped the posts and saved them locally, ready for whatever you want to do next. Request, pacing, and monitoring. Your setup is only half the battle. How your script behaves matters too. Use random dot uniform open parenthesis, close parenthesis instead of fixed delays, and don't rush. A little patience usually gives better results than trying to scrape as fast as possible. If you start seeing empty pages, missing posts, CAPTCHAs, or login checkpoints, stop and check your setup before continuing. Most issues come from moving too quickly or changes on the site's side. The bottom line, a good browser profile helps, but smart pacing is what keeps your scraper reliable. The nice thing about this approach is that you can adapt it to different kinds of projects depending on what you're trying to accomplish. 1. Scraping public pages. If you're only collecting information that's already publicly available, you don't need to log in at all. Just launch your browser profile, visit the page, and start gathering the data you need. In most cases, this is the simplest setup because you don't have to manage an authenticated session. 2. Working with logged in content. Sometimes the information you're after is only visible after signing in, such as content inside certain groups or posts that aren't available to anonymous visitors. In those cases, keep each account in its own GoLogin profile and avoid mixing browser data between different accounts. Keeping sessions separate makes them easier to manage and troubleshoot over time. 3. Running a one-time research project. Maybe you're putting together a report and only need data from a handful of pages. In that situation, you can create a single profile, collect what you need at a steady pace, export the results, and you're done. There's no need to overcomplicate the setup for a one-off task. 4. Monitoring pages over time. If you're checking the same pages every day or every week, consistency becomes more important. Reusing the same browser profile means your environment stays the same from one session to the next instead of looking like a completely different browser every time. It also saves you from having to set everything up again whenever you run your script. The biggest takeaway is to choose the approach that matches your project. A quick research pull doesn't need the same workflow as long-term monitoring, and keeping your browser profiles organized will make managing multiple sessions much easier. Common problems and how to handle them. Even with a good setup, things don't always go as planned. Here are the most common issues you might run into and what they usually mean. Facebook starts showing CAPTCHAs. If a CAPTCHA suddenly appears in the middle of your session, it's often a sign that your browsing pattern has attracted extra scrutiny. The first thing I do is slow everything down. Increase the delay between actions, take longer breaks between page loads, and if necessary, switch to a different residential proxy before trying again. Posts are loading, but they're empty. This is one of the trickiest problems because the page looks like it loaded successfully, but the data isn't actually there. When that happens, double check your browser environment, verify your fingerprint on IPHey.com, and consider testing with a different IP if the issue persists. Facebook asks for a login checkpoint. Sometimes you'll be prompted to verify your identity or review account activity before continuing. If that happens, pause your automation and complete the verification through the normal account recovery process before using the accounts again. IPHey reports problems or detects leaks. Before scraping anything, make sure your browser profile looks consistent. If IPHey highlights issues such as mismatched settings or WebRTC leaks, fix those first. Regenerate the browser profile if needed and verify everything again before continuing. The script says it found 0 posts. Don't assume the page is empty. Websites change their layout from time to time, which can break the selectors your script relies on. Open the page in your browser's developer tools, inspect the elements you're trying to collect, and update your selectors if they've changed. The biggest lesson is not to panic when something stops working. Most scraping issues come down to configuration changes, updated page layouts, or temporary restrictions, and taking a few minutes to diagnose the problem will usually save you hours of frustration later. Common myths about Facebook scraping. There are a lot of misconceptions about scraping Facebook, especially if you're just getting started. Here are a few of the most common ones. Myth 1, a simple downloader is enough. It might seem like downloading the page source should give you everything you need, but that's often not how modern websites work. Much of the content is loaded after the initial page through JavaScript, so if your tool only grabs the raw HTML, you may end up with an incomplete page rather than the information you're looking for. Myth 2. Using Selenium with a proxy makes you invisible. A proxy changes where your traffic appears to come from, but it doesn't automatically change how the browser itself looks to a website. Browser configuration, automation signals, and other characteristics can still be used to identify scripted activity, so using a proxy alone isn't a guarantee against detection. Myth 3. The faster you scrape, the more data you get. It's tempting to speed everything up, but that's not always productive. Making requests too quickly can lead to throttling, temporary restrictions, or incomplete results. In practice, a steady and well-tested workflow often produces more reliable data than trying to process everything as fast as possible. Myth 4. Any proxy will do the job. Not all proxies behave the same way. Different providers and IP types have different reputations and performance characteristics, and some may be more suitable for certain tasks than others. The right choice depends on your project, reliability requirements, and the websites you're accessing. The biggest takeaway is that successful data collection isn't about finding a single magic tool. It's about combining the right browser setup, sensible pacing, reliable infrastructure, and regular testing to make sure the data you're collecting is actually accurate. Facebook is a goldmine for research data, but it has one of the most aggressive anti-bot systems on the internet. You need a real browser to render dynamic content. You need a clean fingerprint to avoid detection. You need a residential proxy to look like a normal user. And you need conservative, randomized pacing to stay under rate limits. GoLogin handles the fingerprint and proxy automatically. Python with Selenium handles the browser control and data extraction. Pandas saves everything to CSV. Verify your setup on IPHey.com before every session. Start with a small test batch. Watch for soft blocks. For ongoing monitoring, always reuse the same profile. That's a complete stack, and it works. If you want to follow along at your own pace, I've linked the full article in both the description and the pinned comment. It includes the complete code and works well as a step-by-step reference while you're setting everything up. And if you decide to try GoLogin, don't forget to use my promo code at checkout. It'll get you 40% off your plan plus an extra 2 gigabytes of proxy traffic. If you found this video useful, I'd really appreciate a like. It helps the channel more than you might think. And if you've got any questions or run into issues along the way, leave a comment below and I'll do my best to help. Thanks for watching, and I'll see you in the next one.